Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 284, count artifacts that can be extracted. So there are a lot of strangeness about this problem that lets you do it in a essentially brute force, to be frank. But you may not have noticed it if you have to read everything and to the end. And there's a lot of things to read on this one. But and I think one thing that and I'm just gonna complain a little bit, but not really a complaint. But I think my understanding was a little bit weird in that usually you would do coordinates on the corners of these things and not like as cells. So it's a little bit weird, but maybe not that weird. Maybe I just kind of had trouble reading from that as a result. And I took 5 minutes, which is kind of long for me for this kind of problem. But it is just bookkeeping. And the other two things that you would have to make sure is that the two artifacts do not overlap. Each artifact only contains 4 cells. But I think that doesn't even matter that much, but only that the two artifacts don't overlap and the digs are unique. So you don't dig the same place more than once. And that's good enough in a reason that I'll explain in a second. But while you do that, you should dig into hitting the like button, hit the subscribe button, and join me on Discord. Dig into that. I got nothing. But basically the idea behind these three thingies, these three constraints, and also I want to give some props to the Leetcode team, because I think one thing that I have said in the past is that I hate that they kind of hide constraints in the they hide these things in the constraints, and then like you have to scroll down and be like, oh, that changes the problem. But no, this time they put it up on top, and so I think I mentioned this a couple of times, and I don't know if they're watching this or whatever, but I still want to say I appreciate that they listen to feedback, even if not direct or whatever. So props to them there. These three things, what does that mean, right? Well, first thing to notice is that n is equal to 1,000, and because it's an n by n, I think it's n by n, right? Yeah, n by n grid. That means there's going to be 1,000,000 entries. Of course, there is these things that are less than 10 to the 5th items, but that doesn't even matter in the sense that, it matters in a way in that it's just about like IO performance, but it doesn't matter in terms of the grand scheme of things. But because these two artifacts do not overlap, what that means is one thing, right? Which means that if two artifacts do not overlap, no matter what you do, the artifacts don't overlap, which means that there are 1,000,000 cells. Each cell will only be painted once, right? There's only going to be one artifact in it. So that means that you can write a for loop, and that means that every cell will be quote unquote painted once. That means that you'll do at most 1,000,000 paint operation of a very cheap O(1) operation. So this is good enough to make sure that this is quote unquote linear okay, maybe not linear, but that n square will be the bound if you just do a for loop through the artifact. So that's one thing to notice. Even though this looks, because without this constraint, you can imagine that you have one artifact that takes the entire size, and if you do a naive for loop and you paint everything, and then the second artifact would do the same, and then because there overlaps, that could degenerate into n to the 4th, right? And that's a common thing that happens. But because it doesn't have overlap, it becomes n squared, which is the size of the grid, which is 1,000 square, which is 1,000,000, right? So that's good enough, that's Gucci, and that's one thing. The other thing is that the entries of dig is unique. That means that you don't have to, depending on how you implement it, you don't have to worry about the same place keeping track multiple times. So you could actually have some implicit thing there. Michael does not take advantage of it, but you can do that. The other thing is that the number of cells covered by artifacts is almost 4, which I actually don't think matters in this particular case, except for maybe some of execution time things, but otherwise it doesn't matter, as long as you keep everything within n squared, which is 1,000,000. And that's basically the idea for this problem, and that's basically my code. For each artifact, I keep track of the set that it cares about, and then I do a lookup from the artifact to the index, right? And then on every dig, I look up what artifact numbers you go to, and I remove it from that set. Technically, this isn't even necessary. You could actually have a counter and then just decrement, because the entries of dig are unique, so you're not going to dig the same spot multiple times. But I just wanted to, I don't know. I just thought this was a little bit safer, though. Technically, I actually don't know if this removes if it's not in there, but yeah, but luckily it didn't come up anyway. So yeah, and then at the end, for every artifact, if there's nothing left to uncover, then you increment that artifact, and that's pretty much it. So yeah, so in the worst case, this is going to be n squared. For example, you have one artifact and it covers the entire n by n, so that's going to be n squared. But like I said, the total amount of coverage can be n squared because there's no overlap, right? So yeah, so this is at worst all of n squared in total, even though there are 3 for loops and it may look confusing. Because you can say in a naive way, you could say this is n squared and this is, I don't know, m, so this could be m times n squared, but because of the no overlap rule, this is only going to be O of n squared time and space. For dig, this is obviously O of, I don't know, d for dig. Yeah, and this is all O of 1, so yeah, and then here, this is another O of, I don't know, A for artifact. So in total, the time is going to be O of n squared plus d plus A. And that's pretty much it for time. And for space, let's see, what is space? Well, this is going to be linear in the size of the input-ish, because at most there are 4, and this is A, so A is going to be O of A. But that's also bound by n squared, so this is going to be O of n squared space in the worst case. Yeah, that's pretty much all I have for this one. Let me know what you think. Let me know how you did it and in the comments below. But you can watch me solve it live during the contest next. Wait, weird to read problem. Okay. This is like a reading contest. And by n, okay. Also, why would you not describe these by the corners of the coin and not the cell? That's really weird. That's why I'm having trouble with this one. Okay, fine. They don't overlap. The entries are, and it's 1,000. Oh, I mean, this is just sort of set thing, right? Okay. Let's see. Okay, fine. a timeout, but it should be correct. Maybe. Okay. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. But more importantly, stay good, stay healthy, take good mental health. I'll see you later and next time. Bye-bye.